coming to you directly from this classroom. Who would sponsor us? Carl's Jr.? That would be awesome. Sonic? Maybe. Yeah. So, given two polynomials, P of x and D of x. P of x and D of x. Then P of x divided by D of x is what we're going to be doing today. We're going to take one polynomial, divide it by another polynomial, P of x divided by D of x. That's going to equal Q of x. Now this is all just represented symbolically. This will make a lot more sense here in a second. This is going to equal Q of x plus R of x over D of x. Makes sense, right? Okay, moving on. Anybody lost? There you go. There you go. You guys, I know that you know this. I know you do. Check it out. If I ask you to divide 100, let's do 422 divided by 13. If I add, this is not what we're doing today. This is like second grade stuff, but if I asked you to do 422 divided by 13, wouldn't that look like this? 422 divided by 13. This is just a long division algorithm. How many times does 13 go into 42? I think it goes in 3 times. 3 times 13 is 39. If you take 39 from 42, you get 3. Now you drop down the next digit. 13 into 32 goes twice. 2 times 13 is 26. 26 from 32 is 6. So, this is the result of the division. So if 422 is divided by 13, the answer is 32. But did it go into an even number, or did it go into it completely? We have this remainder. So we add the remainder, 6 over 13. That's exactly what this is saying. If you divide two things, you have a quotient plus a remainder over the divisor. You seeing it now? Yeah. Okay. This is what's called the quotient. And I'm going to be using these words, so you need to know what I'm talking about. That's called the quotient. What's that called right there? This right here. That's the remainder. This down here at the bottom is called the divisor. The term that you were originally dividing is called the dividend. Now, most every student is more comfortable representing the answer like this. I will, however, tell you, if you can get comfortable with what I'm about to write, then Tuesday's lesson is going to make a lot more sense. Write that down. How could we have checked our answer? How do we know that 422 divided by 13 really is 32 plus 6/13? Well, you take 13 as the divisor multiplied by the quotient. And because 13 times 32 didn't go completely into 422, wasn't there 6 left over? So you have to add the remainder. Okay? This is more along the lines of what next time's lesson is about, and the lesson after that. Okay? You're going to represent your answers today this way, but this also has a lot of validity in what we're about to do. Because, what if there wasn't a remainder? What if the remainder was 0? What does that mean about your dividend compared to the divisor? Don't they go into each other completely? Okay. That also means that you found two factors. If the remainder is 0, then haven't you factored the original dividend? Just keep that in mind. If there's no remainder, then you factored it completely. So, here we go. Example 1. We're going to divide, and this will be the last thing that we do. We're going to divide 6x squared minus 26x plus 12. We're going to divide that by x minus 4. So what we do is set up the long division algorithm. We have to have a long division bar. Inside of the long division bar goes your dividend, which is 6x squared minus 26x plus 12. Outside of the long division bar goes the divisor, x minus 4. The process is very, very similar. If you guys are okay doing this process here, this process is almost exactly the same. There's some slight differences, but it's pretty much the long division algorithm. Really what you have to focus on is first term here compared to first term here. That's it. How many times does this term go into that term? How many times does x go into 6x squared? 6x. Let me erase that. That got kind of messy. Here's another way you could tell. If I took this term and divided it by that term, if I took 6x squared and divided it by that, what's left over? So that's how many times it goes into it. It goes into it 6x times. Okay? So I'm going to put a 6x right here, because x goes into 6x squared this many times, 6x. You following? Now, it really doesn't matter up above where you put it, but I kind of like to keep the things lined up. Since this was a linear term, I put it above the other linear term. That's just me. Okay? Now that you've come up with this term, you multiply this term with both of the terms in the divisor and write it underneath here. 6x times x is 6x squared. 6x times negative 4 is negative 24x. And the reason it has to be done this way, if you drew a line and then subtracted, what happens to that first term? It has to cancel. If you don't cancel your first term, then this process is going to continue indefinitely. But as you continually cancel your coefficients or your terms, you're eventually going to get down to smaller and smaller terms that can't be divided by your divisor anymore. Does that make sense? You always have to make sure that you cancel out that first term. So those cancel, but what's minus and a minus? So we're actually adding 24 to negative 26. We're not subtracting 24, because here we have a negative times a negative. So negative 26 plus 24 is negative 2x. Now what do you think we're going to have to do? Drop down the next term and begin again. How many times does x go into negative 2x? Negative 2. And again, if you're having trouble seeing how many times one thing goes into another, just take the two terms and divide them. If you have negative 2 and divide it by x, what are you left with? So that's the term that goes right here. Negative 2. Negative 2 then multiplies this polynomial, and you get negative 2x plus 8. But you have to remember, draw your line and subtract. Negative times negative 2x is a positive 2x, which cancels that. But this really turns into a negative 8. If you take that from 12, you get 4. Okay, I need you to write this down. By this, I mean this right here. Because this has smaller degree than the divisor, is the remainder. Many students mistakenly think, well, because there isn't anything else to drop down, that has to be the remainder, and that's not true. This term becomes the remainder because this degree is smaller than the degree of the divisor. Okay? What I mean by that, if you take a look at this divisor right here, what's the degree of that polynomial? It's degree 1. This is kind of confusing, but just go along with it. What's the degree of a constant? I think I've talked about this before.
Not 1. It's a 0.
A constant is considered to have degree 0. Why is that? There's no variable. Why is there no variable? It's because it's this. What's x to the 0 power? 1. And what's 1 times 4? 4. So anything that's a constant is considered to have a degree 0. So this has a degree that's less than that, right? That means this is the remainder. Sometimes you're going to have a remainder that has variables. It doesn't have to be a constant to be a remainder. It just has to have a smaller degree than the divisor. So how do we represent the answer then? What's the quotient? So 6x minus 2. Now we have to add the remainder over the divisor. So we add what? 4 over x minus 4. And that's your answer. If 6x minus 26x plus 12 is divided by x minus 4, the result is 6x minus 2 plus 4 over x minus 4. Now the bell's going to ring here right now, but I want you to write this down as well. Don't leave. This also means that 6x squared minus 26x plus, what was it? Plus 12 is equal to, parentheses, 6x minus 2 times x minus 4 plus, what was left over? What was left over? 4. You also need to consider that. Okay, that's it.